afternoon, friends. Good afternoon, friends. Myself, Dr. Kushal Bhattacharya. Today, I should be solving some problems on friction clutch. So, the first problem I should be doing with the single plate friction clutch. Next, we should be going for other different cone clutch or multiple plate clutches. So now, the first problem you just see on the board what I'm showing. So a plate clutch. It's given a plate clutch consists of connecting surfaces. A plate clutch consists of a connecting surface. The inner diameter and the outer diameter of the friction disc are 100 mm and 200 mm respectively. The coefficient of friction is 0.2 and the permissible intensity of pressure is 1 Newton per millimeter square. Assume uniform wear theory. Calculate the power transmitting capacity of the clutch at 750 rpm. Now this is the given. Now this is the problem which is given. Now from this problem, important thing, what are the given criteria? First, see, if you see what are the given criteria, first of all, you see the given is D. The diameter is given, which is 200 mm, the capital diameter of the clutch, and then the smaller diameter, inner diameter. If you try to imagine this, the single plate clutch, if you try to imagine this is the outer diameter and this is the inner diameter. So this is the outer diameter is given 200 mm and the inner diameter is given 100 mm. Now coefficient of friction mu is given 0.2, intensity of pressure is given 1 Newton per millimeter square, and n number of you have to calculate the power transmitting capacity of the clutch at 750 rpm. So n is given 750 rpm. Now we know that for a uniform pressure, now you know that for assuming uniform wear theory. Now from uniform wear theory, we know the applied load is given this. This is the applied load is given for the uniform wear theory. Now from this, we get the value of pi. We know the value of p pi. Then we put the value of the maximum intensity of pressure. Then the diameter D, capital D, which is 100 mm. Then 2 minus 2, and we get this value of this applied load. Now the torque. What is the torque? Again, for uniform wear theory, you know this is the torque transmitting capacity or the friction clutch for the uniform wear theory is given in this form. So from this form, we know the value of this P. This the applied load is calculated. We put the value of this applied load. We get the value of the capital diameter plus the smaller diameter. Then we calculate this value. This value comes to about 235,619.4 Newton per millimeter square. Now the power transmitting capacity. The power transmitting capacity remains the same, 2 pi n nt 2 pi nt by 16 to 1000. So this is the torque. So power is equal to 2 pi nt by 16 to 1000. So when you put this value of this T, you get the power transmitted, and the power transmitting capacity is 18.51 kilowatt. Now we should start discussing problem on multiple disc friction clutch. A problem starts with a multiple disc clutch consists of 5 steel plates. The inner and outer diameter of friction discs are 75 mm and 150 mm respectively. The coefficient of friction is 0.1 and the intensity of pressure is limited to 0.3 Newton per millimeter square. Assume uniform wear theory. Calculate the required operating force and the power transmitting capacity at 750 rpm. So this is a plate. This is a problem of a multiple plate clutch. Now if you remember multiple plate clutch, so how it operates. So basically all the assumptions remains the same, but you have to consider the number of plates. Here a small formulation has been changed for the torque transmitting capacity. Apart, the other things remains the same. So now if you see what are the given criteria, the given is the diameter D, the smaller diameter D, the capital diameter D is given, the coefficient of friction is given, the maximum intensity of pressure is given. Now for uniform wear theory, as has been asked in the problem, for the uniform wear theory, this is the formulation for P, this is the formulation for the applied load. This is the formulation for the applied load. Now over here we put the value of the maximum intensity of pressure, the smaller diameter, and we get this value of this applied load. This is the value of this applied load, P. Now as you know, there are 5 steel plates and 4 bronze plates are there. There are 5 steel plates and 4 bronze plates. Suppose if you take the plates like this, if you assume the plates are like this, so this is the contacting surface, this is the contacting surface, another one steel and another one is of bronze. This one is of bronze. If you assume this one is of bronze, so number of contacting surfaces, so this is 1, 2, and if there is 3, 4, so if there are 5 steel plates and 4 bronze plates, so number of contacting surfaces depending on this, there should be depending on this into 4 into 2, because 2 surfaces, that is 4 into 2, it becomes 8. So number of contacting surface becomes 8. So for this reason, this is the formulation where everything remains the same, only this value and this value is added. You know, in the deduction, if you follow the deduction, this value of Z is added. So apart from this, so Z, apart from these other things remains the same for transmission of torque. So for this you put the value of mu is equal to 0.1. You have calculated the applied load from here. You have calculated the applied load. This is the value of the applied load. You have calculated. You are putting this value of this applied load, putting the value of mu, and Z, the number of which I just told, number of contacting surface 8, and 150 by 1 by 50 over this. By putting these values, you are getting this torque in this form, 119282.4 Newton meter. So this is the value of torque you have got. Now for calculating the power remains the same, 2 pi nt by 16 to 1000. So in the place of T, that is the torque, you put this value of torque and you get the power as 9.37 kilowatt. Okay. Now we should be discussing about a cone clutch, a problem on cone clutch. So the problem is given like this. A cone clutch with asbestos friction lining transmits 30 kilowatt at 500 rpm. The coefficient of friction is 0.2 and the permissible intensity of pressure is 0.35 Newton per millimeter square. The semicon angle is 12.5 degree. The outer diameter is fixed as 300 rpm for space limitation. Assume the uniform wear theory. Calculate the inner diameter, the face width of the friction lining, and the force required to engage the clutch. Another portion is given, the theoretical portion. The semicone angle is taken as 12.5 degree. Why? Now, before we are going to discuss this problem, we should focus. So we should first see what are the things given to us. First, the thing is given power. Power is 30 kilowatt is given to us. Given parameter N 500 rpm is also given to us. Then coefficient of friction mu is also given, 0.2. Intensity of pressure 0.35 Newton per millimeter square. This is also given. And the semicone angle alpha, this angle, is given as 12.5 degree. So these are the parameters given to us. Now, what are the things not given to us? What are the things we require to find? The smaller diameter D. This we are going to find out the smaller diameter D. This smaller diameter we have to find out. Then we have to find out this face width of the friction lining. This is face width of the friction lining. So if you recall my previous class, this is the region which will be in contact. So this is so it has been asked to find out this face width and the applied force F required to engage the clutch, and the applied force F required to engage the clutch. These are the things, these are the parameters we should be going to find out. Now you see how. First we know that for a uniform power is given. To calculate power, this is the formulation for any, for uniform pressure, uniform wear, 2 pi n mt by 16 to 1000. Now mt is given as, now if you, this is the, this parameter is not given to us, this that is the torque requirement, so mt is also is not given to us. So mt, for calculation of mt, we reverse it out and put this value of p. This p is known to us, this p is a known value, this p is known value, this pi, this n is also known value. So we put all these values of values over here, and we calculate the torque transmitted. This is the torque transmitted by the cone clutch according to uniform wear theory. Now according to uniform wear theory, we know this is the formulation. mt is equals to mu pi pa into d by d square minus d square by 8 sin alpha. So we know this value, we know this value of mt, we put this value of mt and we calculate all other parameters. Capital D is known to us, capital D is given, is this d 300 mm, this is also given to us. So we put all these values over here and we get a form like this, we get a form like this, we get a form like this. So we get a form like this. Now with this form, we use trial and error method, and we calculate the value of small d as 270.8 millimeter, which is approximately taken as 270 millimeter. Now we know that according to this diagram, according to this geometry, so this width b can be find out by as d by twice sin alpha. This b can be find out as d by d into twice sin alpha. So if you put the value of d, capital D 300 and 270, which we have just got as a small d, we put the value of small d 270 and 2 sin alpha 12.5 degree, we get this breadth as 69.3 millimeter. We get this breadth as 69.3 millimeter. Now we should be going to find out the force required. This is the third portion. The first one is we have calculated out the first portion which is required. This is the first one, the inner diameter we find out. The face width we also find out. Now the force required. Now the force required for uniform according to uniform wear theory is given as 4 mt sin alpha by mu d plus d. Over here we know this value of mt, so we directly put the value of mt over here. Sin alpha we know, we put the value of capital D, and this small d is also known. So we get this value of the applied force as 435.25 Newton. Now a question comes, the fourth one, why this is 12.5 degree? Why this angle is 12.5 degree? Why this angle is 12.5 degree? This, if you find my lecture, if you find my previous lecture, so I have explained why this alpha is 12.5 degree. I am explaining once more why this alpha is 12.5 degree. Now you see that alpha, according to this equation for mt, according to uniform wear theory, it is given like this. mt is equals to mu p or 4 sin alpha d plus d. Over here, if we know this value of p, if we know this value of d plus d, so only variable quantity is mt and sin alpha, which is inversely proportional to sin alpha. So which indicates that if sin alpha is lower, if this value of sin alpha is as low as possible, if this value of sin alpha is, if this value of inversely proportional means as the sin alpha decreases, mt will be more. So if we design that, if we reduce more and more the value of sin alpha, what will happen? The torque carrying capacity will increase. Now there is a limitation. If alpha becomes less than the coefficient of friction, coefficient of static friction, then what happens? If alpha is less than 5, then what happened? Then self-engagement will take place. Then coefficient of static friction 5. So if alpha is less than 5, so what happened? Self-engagement will take place. When self-engagement will take place, what is the problem? So once the gear is engaged, once the clutch is engaged, once the cone clutch, inner cone clutch is engaged with the outer cone clutch, so what is the inner cone clutch is connected with engaged with the outer cone clutch, it is very difficult to remove because it is self-engagement takes place. Now it is not desirable. What is desirable thing is that we should engage and disengage the clutch according to the will of the operator. So if a self-engagement takes place, so it is not beyond our control. For that reason, what happens? We take the value of if we take the value of mu is equal to 0.2, if we take the value of mu is equal to 0.2 and calculate calculate the value of alpha, we get the value of alpha is 11.3 degree, which is normally taken as 12.5 degree. So we end over here the discussions of all this. First, we have solved what are the problems we have solved in this lecture. First of all, we have solved for a single plate clutch according to uniform wear theory. Then we have solved for multi-plate clutch. Then we have solved problem for a cone clutch. Okay, thank you. So if you like my video, put a like mark to it and have a good day.